so this is a sacrifice you guys made to get me here. I'd like to have a half hour to ramble on about stuff that I'm working on. Come for the auto stage reviews.
Is that potentially a slam on Brian or against both?
All right, so yes, I did. Oh, you want me to use it too? Wow, you guys are demanding.
So what time do we have to leave? What time are we going to leave? 12? What time we're going to leave? 12? 12? 12, okay. Do you have until 12? We can go ahead and take it.
Yeah, let's do that then. All right. So I want to talk about stuff, about how I take things. So, you know, one of the things I like to do is if I keep doing a task over and over and over, I want to automate it. I don't ever want to tell, when I'm designing APIs or other things to be used, I want to tell, remember to do this thing. If you have to do it every single time, the compiler should remember that for you. So I tend to do a lot more automation in this way. I think overall it makes the code safer, easier, and more robust. So that's a running theme throughout with this. And also that if we're going to have complex code, put it in one place. Have one piece of really complex code and make the rest of the code simpler. One of the things I've been trying to improve in traffic servers having this hand-rolled weirdness, like the alpha to integer conversions, where we have literally 6 or 7 different implementations, all of which are slightly different. Better to have one piece of fairly complex conversion code that's then called everywhere to make it more simple. All right, so there we go. There's philosophical stuff for you. So one of the projects we're actively working on is plugin coordination, making a plugin happy family rather than just a bunch of feuding pieces of code. So we did get some work on this done. Zeyuan put up a PR for this for phase 1. If anyone remembers the last one, we had originally 6 phases, which we cut down to 4. So this was phase 1. We ended up having some problems with it, so it got closed, but we are working on it. We have the equivalent of this in our production fork of traffic server, so this is now being production tested. The Verizon Media CDN is running with this plant, with this code. We want to bring it back for ATS 9. What this really does is try to provide a unified dispatch mechanism. So right now, the session hooks and the other hooks are all dispatched by, again, hand-rolled bits of weirdness everywhere. And the real goal of phase 1 is to say, let's have a unified piece of code that does this dispatch. And then we can do the other stuff by tapping into that. Hopefully, sometime this summer, we'll start working on phase 2, which is we'll start doing plugin introspection. So from a plugin, you can ask about what other plugins are in the system and what are their properties. I guess I should mention that the ultimate goal of this is to be able to have plugins coordinate with each other, right? That's the name of the project, because this has actually come up again for us where we want to say, well, we want plugin A to run before plugin B. And other people have had that request too. You know, I get people glare at me when I say, well, you put the plugins in, you'd hope for the best for the ordering. Miles is glaring at me right now. I'm trying to get things done to fix that. One of the things that's made this worse is that we have a lot of additional hooks, so that's going to be more fun. The SSL hooks, the lifecycle hooks, weren't in there when the original prototype of this was running. So and then phase 3 is what you're all looking forward to. That's when we can do the callback ordering. But you have to have the introspection first. You can't say I want to run after A if you can't reach out and say what plugin A is. So we have to have this introspection level first, and then we can do that. All right, well, that's enough about that. Another side project that I got, do you have a mic?
Does any of this include plugins sharing data better? So we have wonky stuff today with the transaction slots and the session slots and.
Yeah, well, that project hasn't been really worked on since the last summit, unfortunately. Mostly my fault. That's the whole extendable thing, which turned into a much bigger thing because of you. Than it was originally planned after that working group in Denver. I do hope to get back to that this summer, but that was the point of the extendable was to make this information sharing better so that I can, in plugin A, say, I want to extend the vcon object to have this extra structured data. And then any other plugin can reach in and look at that structured data. So you have these very nice constructed and destructed things. You have much better control of not losing memory through the transaction args. That's a continuing problem. So the answer to your question is the extendable work that Aaron is doing is our work on that subject. And I'm trying to get back to it. He's waiting on my review, so, and it's not trivial code, and I got to psych myself up for reviewing it again. Any other plug-in questions? All right. Matrix parameters. I don't know how I got sucked into this, but this actually was an issue inside VMS, Verizon Media. Complaints. So this is where, I know Phil worked on this a long time ago, and maybe the Geffen touched this too, where you can put these semicolon things. Yeah, I know that was there, but we have now an internal request for this. So this has really been challenging. We'd like to actually work with those. The problem is you can't just put a view around them because they're scattered among there, so you have to have this ability to index them. One of the things I want to be able to do is start with an option when I get this done to say, well, I just don't care about matrix parameters. When you see them come in, just strip them and throw them on the bucket. And I think that would cover about, frankly, 95% of the use cases. I don't think it's very, very rare that people actually use these. One of the things that I'm working on with my Memorina stuff, which we'll talk about later, is that we can do allocate views and descriptors of these things relatively cheaply with minimal runtime allocations. Right, we amortize them, so we do a bunch of allocations there. One of the other projects I've had on and off, which I never get worked on, is a split vector class. So if anyone wants to look for a cool STL project that would be useful to traffic server, split vector would be a great one. What this says is I'm going to have, it looks just like a standard vector, except I can give a static parameter to it to say, well, always have statically n elements. So you pass 10, say. So it always has 10 static elements. And if your vector is never longer than 10, it uses that static area. Right? If it gets bigger than 10, then it copies it over to a new vector that contains the extra area. And this would be, it wouldn't eliminate allocations, but could greatly reduce them. Because frankly, like for the matrix parameters, there's not going to be more than 3 or 4 of them, period. Right? So you say, I want a split vector that's 4. And then it never allocates, right? Unless there's at least... yes, it's the same kind of concept, right? You say, I'm just going to have just a standard... What you do is you'd have a standard array and a standard vector. And the standard array would be whatever size you say, and when you run out of space, then you switch to the vector. But as long as you stay within that array size, you don't do an allocation. And this is not just useful here. There's a whole lot of places in Traffic Server where we could use this, right? You can see it all over the place. Like the fragment table was one. And I know there's an array and there's multiple. So anyone's looking for a project, this would be cool. And what you'd want is you want the interface to look as much like standard vector as possible. So it's just a drop-in replacement, right? Yeah, it's something I invented. No, I haven't seen anyone else look at that. You know, it's not conceptually hard or challenging in programming. It's just a lot of work because you have to do all the API stuff. But it's really not complicated under the hood, right? It fits in the array or it doesn't. When you do a pushback, you copy or don't, right? It certainly would be simpler than the crap we have now that does this. Maybe it doesn't really work as well in other containers. And if I look at Traffic Server and the use cases where this would be applied, they're almost all vectors arrays. So this would handle at least 90% of the places that would be useful currently. What? Yeah, let me go through it for this particular case here. So we have matrix parameters, and we say, okay, well, we have to have a vector that says here's an array of views of the matrix parameters in the URL, so I can iterate over them, right? So I say, well, I've looked at my traffic, and 99% of the time, there's no more than 4 matrix parameters. So I say split vector of 4, and then I make that a member of the state machine. So if there's 4 or less matrix parameters, there is no allocation. We have no additional allocations for handling those. Only if there's more than 4, which is 1% or less of the time, do I allocate a vector and have to actually store that. So the benefit is that we, in the general case, reduce the number of memory allocations that are done in the critical path. That's the point of it. And yeah, and Leif was just ranting on about that. So, right. Because in real life, frequently, there's a 90, 95, 99% case, which isn't very large, and you can say, well, we'll just statically allocate that. But having to handwrite the code all of the time, this is my philosophy again, is flaky and not good. Oh, there's all, yeah. So yeah, and I would like to get to it. I don't know if I can. Anyone else? Hey, PR is welcome. Anyway, this ended up doing, you've noticed I did a bunch of MIME header cleanup stuff, and it was actually driven by trying to get to the point where I could do the matrix parameters, though it has other benefits. I'm trying to move us to string view more as a base, so there's been a bunch of PRs there. All right, this is another one. This is hard to explain. It's something that Leif bugged me about a long time ago, and I've been trying to work on this. We have this structure, HTTP config, which has a bunch of data elements that are for runtime data for various subsystems. All right, has anyone seen this besides me? All right, I'm the only one who's looked at this. Take my word for it, it exists, right? The problem is that because it's this unified structure, anyone who gets the HTTP config has to include the headers for everybody else who has a piece of the HTTP config. So you end up with this huge mass of includes, right? Just this, you know, and you can have nasty circular dependencies in some of this stuff because of the way these headers have to include, right? Because you have this one thing that gets past the subsystem, which means that subsystem has to include headers from every other subsystem with data in it, right? So what we want to do is we want to flip that. We want to say, okay, I want the subsystem to define its piece of the config. And when I talk to it from the core, I will hand it just its piece of the config. So it has no need to know about any of the data structures, any of the rest of the config. Right? So we cleanly piecemeal out the config to the various subsystems. Each subsystem says what its piece is, and it only gets talked about. And it cleans that up. So I'm the cache, and I've got this cache runtime data. I say, here's my cache runtime config thing. Hand it to me every time you do a cache call to tell me, you know, TTLs and timeouts and stripe allocations and all of that stuff. And I don't have to include the DNS config data, which is currently what it has to do. And so that's what I made my inversion. We're flipping that around. I've done some work on this. The key thing is that we have to have some magic here that lets the do conversion between the management types, which is just the API uses, and the actual config types. This is some of the enumeration stuff you saw. If you saw that go by recently, we put in. I've done this for the, I've worked on it some for the cache, and I've done some work with it for the HTTP connection counting. So there's the base code is here. I just need to work on more. I just don't want you to be surprised when you see this going around. So yes, we just talked about this. And then the cache just, I mean, this is what you originally complained about, right? So then we say the cache says, here's this cache config. It's a member of the HTTP config, and you just pass that piece in whenever you talk to the cache. Right, and we have to do these conversions. Okay, yeah, this is kind of a dog's breakfast of a talk. HPSM logging, this is another thing that came up recently. There's a bunch of data that hangs out in the state machine for no reason other than we will eventually want to log it when the transaction shuts down. Okay, and it can be really hard to tell when you're looking at the code and you're trying to figure out what's going on is why is this data here? Right? Is it actually used? Does it actually matter? What happens if I change it? We've had bugs where people change these things, but because they're logging data, it just has no effect for no apparent reason, right? So right now this gets cached, and again, it's spread out weirdness everywhere instead of one place where we deal with it. Cached in various places, like particularly the client connection information is cached in the VCs. And that makes it hard to clean those up because you can't just get rid of the VC. You have to keep the VC around so you can do the cache data out of it later, even though there's no other good reason to have it. I know Leif and I have talked about this. So what I'd like to do here is to say, let's just add a substructure to the state machine and say, this is where all the logging data goes. If you put something in, if you want the data exists only to log it later, put it here. And then when you're looking at the code, you can say, oh, that's in logging info or whatever. It's just logging. It's not live data. It's just going to get used later for archival purposes. Again, this is not complex, it's just a lot of work, right? But I'd like to get some agreement that we'd like to move in this direction. Yeah, potentially. You might want to look, we can take some of the other cache data out. And I'd rather duplicate it than...
This is how we're building up our transaction, and this is how we close down the transaction. That way you know that data structures are still there at the time that you log.
Yeah, but sometimes it can't be though. Like there is, for example, the recent example was the MPTCP stuff that we did, where that state is stored in the VC.
Correct.
While the VC can be closed long before you get to logging.
Yeah, but you should close it, you shouldn't destroy it.
Well, we do.
I know, that's what I'm saying. Is it there was a clean way of this is how they basically...
But then you need, well, we could do that, but then you have to have good ways of marking to say, hey, this client VC is dead, and make sure everyone knows that, right? One of the reasons it gets destroyed and the pointer cleared out is that no other piece of code tries to access it because...
People do, and that's the problem. That's the whole thing about the traffic server and the shutdowns and running into these, you know, I'm going in and looking at the pointer that the memory did basically free, and it works now because we have free lists. But when we see this in JMalloc, when you go into the JMalloc world and stuff like that, then it starts blowing up. When we start running ACM, we start blowing up.
Yeah, but one of the reasons, I mean...
We don't have a clean way of how transactions are built up and how transactions...
Right, but one of the things that was tried was to say, well, if the client VC or one of these other ancillary structures is dead, I'm going to null out the pointer to it so you can't trace it down. Right, so then if you do that, it crashes immediately with a null pointer reference rather than obscure memory issues. But then you can't log it, so...
But everybody makes a copy of that pointer. You know, says, oh, I'm just going to go, I'm the data structure over here, I'm going to make a pointer to the VC. And I'm the data structure over here, I'm going to make a pointer to the VC. And then you have to go around and track down all those little pointers. You know what I'm saying?
Yeah.
Because everybody got all these different references to some data structure. Then it's been the thing that's been plaguing us for a long time. If there's a clean way, it'd be nice to have like a hierarchy. If this is how we build our transaction, and that way, you have this kind of, you can't go ahead and destroy things underneath you. You know what I'm saying?
Yeah, but because of the asynchronous nature of events, I'm not sure that you can always have a nice linear ordering of things, right? Because a server connection can close first, or the client connection, or some other error can occur. And so the shutdown is going to start at arbitrary places in your graph, not always at the top level. Is where you're going to have problems with that. If you have another suggestion, that'd be great. I think we need to do something here because this it creates chronic problems for us.
Yeah, I see it more. I mean, this is one of the symptoms, but the other symptom is that we just crash all the time because we're keep referencing something that's already
Well, the current approach is non-scalable too. That's the beef I'm having with it. I mean, I agree with you, but it would be nice if we can figure this out in some better way. But right now, the way we have to do this, we do this in at least 3 or 4 different ways, is to call into the submodule, the VC or whatever, right? Extract the data out of it, and then putting it into HTTPSM. And at a minimum, we should be able to do something better. We can at least copy some chunk of memory or something in one operation rather than 5 APIs or something, right?
Well, we might want to put an abstract class in then to say, okay, well, we're in addition to do IO close and the other standard functions, you can have something else that says, you're dead now, just stay around for historical purposes. And you could query that, right? And it could also, in internal state, do things better. Say, hey, you're trying to do this operation, but I was shut down. I'm going to assert or something, so we know immediately you've got this problem.
Inefficient to grab this data. It's also cumbersome to add these APIs because you have to add like getters and setters in 2 layers at least, HTTPSM and the VC or cache VC or whatever it might be, right? It's really hard to add extra code that can get this information that's otherwise lost.
The whole thing about relational data is you want to have a single copy of the data, so things don't get out of sync too.
Right, but
Practice things out of sync. I mean, you'll go ahead and you'll modify the state of something and it'll change here, but yet then you've gone ahead and you copied it for logging.
yeah. Yeah, anytime you copy data, it'll get out of sync. But that was my whole point, is to say, let's just have it one place in the client VC. Let's just use an example. But be able to have the client VC have a state that says, I've been shut down and I exist now only for historical purposes.
Yeah,
so that it can then detect when people are doing bad things, say, and then you destroy it at the end, because really it's very, very important for other reasons to be able to detect that the client VC has gone away. Right? To give you one example, we have to decide whether we're going to send a response. Well, if the client VC isn't there, we want to just cancel that whole thing because it ain't going out. Anyway, but any suggestions people have? But I think this is a chronic problem that just chafes at us continuously, and we need to think of something to do here. And it's a conflict between shutting things down cleanly and logging the data about them later is where the fundamental conflict comes up. All right. So this is something we've been working on. This is what I actually spent the last 3 weeks working on, and Jason and Jesse of our group have been working on this for much longer. And this gets to something, I didn't bring this up when we were talking about it earlier in the opening remarks, but this is one of the approaches that we're trying to take to alleviate the issues that Brian and Leif brought up there, right? So what we're doing here is to say, what we want to do is simulate production level traffic. So we want to be able to take a traffic server or release candidate that we've built, a fork or a master or whatever, and run something that looks very much like production traffic through it and see what happens. Particularly, let's see if, currently our goal is to see if it crashes, but obviously in the long run, we want to do much better than that. The key things we want to do is we want to capture production traffic because, as mentioned, nothing as weird as the stuff you actually see in production. The human mind is incapable of imagining things that weird. So we're only go out and capture stuff that actually happens on the wire, right? Timing issues and other things, it's just weird. Obviously, we need to run at production speed. We also want to have minimal configuration change from production because if you have some very simplified config, you can easily miss production problems because it's not exercising these features. So we want the configs to look as much like production as possible. And we want to run in network isolation. We don't want to risk hitting real production servers or polluting networks or anything like that. So this has to be able to, one of the design goals is to say we could put a separate lab, turn off the internet, and still have the thing run. A lot of pieces of this already existed. A whole AU test project, when we originally started that, this was one of the key end goals of that entire project. This is a place we wanted to get 2.5 years ago when that thing was started. All right, we're finally getting to the point where we're almost there. So we have a replay client, we have the replay server, it's been called microserver, there's some other things going on, the name's not very important. We have the micro DNS name server. Zayuan put in this traffic dump plugin, that's what it was for, so we can capture this traffic data. And then internally he's written a sanitizer, that's currently proprietary. Obviously, we're keeping it in-house right now because it's really crude code. It's not something I'd be proud to have other people see at this point. You know how that goes, right? I mean, all been there. But yes, obviously in the longer run, once we have that cleaned up and sanitized itself, we'll be putting that out. It's not actually that complex a piece of code because the traffic dump comes out in JSON format and the sanitizer reads the JSON and writes the JSON. We picked that so that anyone can build their own sanitizers. Right, so the way this works is the plugin captures production traffic to JSON file. It's session-based, so we, at the start of a session, roll the dice to see whether we're going to capture that session. If we capture that session, we capture everything we can in that session. So it's sample-based. You can set, I want to capture every 1 in 5, 1 in 10, 1 in 50, whatever. We get all 4 request responses, client request, proxy request, server response, price response. And we're not very careful in the plugin because it needs to be as performant as possible. What we do, the sanitizer's primary goal is that after we've dumped all this data, it goes through and it does a bunch of cleanup to get clean data out. So we jump very noisy data out of the plugin and then use the sanitizer to clean up and get clean data. We also remove any sensitive data if you have any privacy concerns or whatever. The point of the sanitizer is also to clean that up too. Then it's pretty simple, right? At that point, the replay client reads the replay file. It uses that to send traffic to the traffic server. The traffic server then talks to the microserver, which also has read the replay file to decide what requests to make. The replay server can run quickly because it doesn't do any decision. It says, oh, I got this request. I'll look up the response. I'll send the response.
So are we recording this all at the HTTP layer?
Yeah, so though it tracks whether it's H2, yes, it does the full protocol stack. So we can see it's V4, it's TLS, it's H2.
But it doesn't log the H2 headers?
Are those different than the request and headers? What's different about them?
There's different headers, there's the colon headers for stuff in H2 versus the non, and those get translated into non-colon headers in H1.
Okay, though then we're probably not doing that.
Just kind of help me out. There may be other things, I don't know about settings or anything like that, that would be nice.
Yeah, well, it has the,
You can kind of guess what the colon headers would be based on the H1 headers. You can kind of almost reverse it.
yeah, there's the things are stored as, there's session metadata and then there's transaction metadata, so it's easy to store that. Gosh, what do you do? So the DNS microserver simply resolves all DNS requests to a fixed pool of addresses to round robin, and this forces, no matter what the request is and what the remap rules you do, it talks to the microserver, the replay server. So that's how we maintain the remap configuration, right? So you can run the same plugins using the same remap rules, and it all works. We are currently actually testing this. The thing that's caught us up in the last month or so is that we haven't been able to get the performance up, but we're actually running this. So yeah, we use remap rules. We can do an isolated network. You don't have to touch anything else. You don't need external resources. We believe this is going to give us more consistent results because it's the same hardware. There's no other network traffic. There's no other upstream servers that can throw off our timing. And this is all about reliability. Susan wants to use it eventually to do additional JE malloc testing, but my whole focus here is on being able to validate traffic server reliability going forward, right? So we're working on a production level testing. Susan and I did work on the replay client and server, and we got it up to about 36,000 RPS, including TLS. So that's good enough. We're going to test at 2,000 RPS. The data size is huge. We're going to have to do something about that. We can currently run now, but we're right at the limit of what we can handle, so we're looking at how to do that. We're having a lot of problems with ephemeral port exhaustion. So Sue's looking at that. So anyway, yeah. So anyway, so this is, the client and server here are actually a separate repo. So although it's not officially released, if you ask me, I'll tell you what the URL is. You can go find it, or you can look me up on GitHub and look through my repos. Be careful with it though. I mean, this is raw code that I was working on like 24 hours before I got on the airplane, so. You have to ask Susan. She does that. She said that was a problem, so she did address splitting to get around it for now, to get up to those performance rates. Gosh, how much time do I have? 6 minutes. All right, so, right, well, we're going to skip the whole half the talk then. All right, great. Well, this is probably a good place to stop then. We've talked about this a bit. Actually, let me go through this. I'll take 2 minutes for this and then we'll stop. So I hate the current RPC mechanism. I've hated it for years. It's fragile, it's complicated, it's bizarre, it does incredibly ugly linking things. You can't change it without editing the core code. It's asymmetric. I really just do not like. What I would really love to do is to rip that all out and make a JSON RPC-based implementation of it. To say I'm going to pass messages that are JSON RPC compliant, and that's what I'm going to reply with. It just wouldn't be that hard. Again, another thing where this is not a really complex piece of code, it's just a matter of sitting down and dotting all the I's and crossing all the T's. It would have immense benefits in terms of standardizing us, and it would mean all the other, rather than having to have this specialized traffic control tool, anything that could do JSON RPC, which is frankly just about every language in current use, you could just write a tool in that language. You could do Rust, you could do Python, you could do Perl, you could do whatever, right? JSON RPC is extremely standard. Everybody has libraries for that. We would use YAML CPP internally to parse it because, well, it's there, it's good enough. There's no point in bringing in yet another library to do what we can already do. And yeah, so what I'd want to do is I want to make it a registration dispatch mechanism when you say, okay, here's my RPC tag, here's a Lambda. When you get this RPC message, hand it to me, I'll do something and I'll return. Then we don't have to change the core code anymore. If I have other pieces of modules that need these RPCs, I can just have at the startup time register my dispatch stuff. In theory, you could even get to the point where plugins could register this, not get rid of lifecycle, plugin messages, and have the plugins be able to register these dispatches, right? So then you could talk RPC, JSON to your plugins directly, which I think would just be huge. And also make it a leaf module. Right now, there's some really nasty circular dependencies in the traffic server code base, and the RPC is probably the worst one. So I'd like to make it it's just RPC, it's just library. Make it leaf. Don't make it dependent on other things, and make it independent. So let's go ahead and stop there.
Question, comment. I think a lot of the complexity that happens today in this existing RPC is due to the fact that we have traffic manager trying to communicate with traffic server asynchronously or actually synchronously. And a lot of this I think we can avoid when we go the route of getting rid of traffic manager.
I disagree. I think it's the other way around. I don't think you can realistically get rid of traffic manager until you do this. I think you still have to have external communications to the running process stack, and I think.
But why would we want to deal with this whole communication stuff that goes between manager and server? Because that's why there's two ways to compile all this.
You have traffic control, right?
Right.
What is it going to talk to?
Sure. And that's what you want to change. But there's a whole other underlying problem with the way things work, and that's the communication between manager and server.
But it uses the same library. It's not.
Yeah, but it gets linked differently. That's the whole sort of the
that is one of the issues.
Right. And that we can get rid of. That complexity can be eliminated completely.
Yes. But it doesn't solve any of the other problems.
No, I understand that. But I'm just saying, getting rid of traffic manager gets rid of at least one or two of your bullet points of complexity.
Yeah, but I think when you get rid of traffic manager, you have to do something else. Are you saying you just get rid of traffic manager and still speak to the whole RPC?
Ugh. Brian and I actually agreed on something.
Yeah, it does make it a bigger project.
I don't think it's that big.
I'm saying if someone wanted to get rid of traffic manager, you can do that, right?
This would be a smaller project than getting rid of traffic manager.
Traffic control talks to traffic server and track.
Traffic control, we would simply have a thread running inside a traffic server that takes over the whole duties of traffic manager.
So you just basically pull that instead of running as a separate process, you run
Right,
it as a thread.
but the fact that it's running as a thread gives it access to all the stuff that you have inside a traffic server, rather than going over a RPC mechanism and manage the server. And that's where I think
Well, you still have to do an RPC.
you're
You're not doing a double work.
right, exactly. We get this sort of, we avoid the RPC between server and manager.
Yeah.
It's all being in one process, we can certainly get to our memory in other ones.
Yeah.
I'd have to look at if it's better to do it that way or
I think you're overestimating.
I'm just saying that
if they're the same RPC.
I think so.
Yes, it uses the same. It sort of uses the same library. It uses the same headers and links in different implementations.
That's why it has all those if that how you compile it like anything program versus
It is a serious mess.
It is.